Welcome AP Stats people. We have lots more words. We got all the way up through bias last time, bias and undercoverage. Now we are going to experiment words. So this is all the rest of the vocab words. I'll do actual experimental design stuff in the next video, and then I'll do simulations after that. So 3 videos coming up real quick. So factors. There anything that might be affecting your variables? I'm going to use this experiment of tennis rackets. So actually I'm going to use an experiment, caffeine. This is the one I use in class. So if I'm giving half the class caffeine and half the class not caffeine, I want to see if it affects their test score next unit. Well, a factor might be anything else that affects their test score or anything else that affects energy. So other things that I would have to worry about if I'm measuring caffeine would be, how did they sleep last night? How do they normally study if I'm measuring test scores? How am I... do they have caffeine every day? Is there new to caffeine? Are they heavier? Are they lighter? Are they affected by the sugar in the caffeine? Should I eliminate the sugar in the caffeine? I got to worry about all these things. Those are all factors. Treatment is what you're actually doing to each group on purpose. So I'm purposely giving a group caffeine or not caffeine. Those are my 2 treatments. Next word would be single blind. So if the subjects don't know what treatment they got, that's called single blind. So if I give someone a fake and someone a real caffeinated beverage, then we'll talk about the word placebo in a second, but that's a placebo is a fake, and then the real caffeinated beverage is the real treatment, and you guys don't know which one you got, that's a single blind study. Now, if the interviewer, the person that gives it to you, doesn't know which one you have as well, that's double blind. So that means both of you don't know. Subject and the testers don't know what treatment's given. The reason for that would be it's easy for people to read humans. You know when I'm angry if I walk into class the second I walk in. So yeah, you're going to know. And you're going to be able to tell, are they giving you a fake? If they know it, they might treat you differently. And so we don't want that to happen. Control group is the group that we're experimenting against. It's your baseline group. You must have a control group in a group. Oftentimes the control group gets a placebo. So that means they're getting a fake. So if I'm doing the caffeine experiment, the group that got the fake is my control group. That's called a placebo. The placebo is there. It's usually a fake medicine, but it really can be a fake treatment of any kind. It's there so we don't trick ourselves into doing poorly or badly based on what we think we got. So if the group that got no caffeine already knows they're not supposed to do as well, they might actually perform worse. And this is called the placebo effect. Just mind over matter. That's really what it comes down to. Self-fulfilling prophecy is the same word. It's placebo effect, right? If you know you got caffeine, you think probably you're going to do better. But if you really don't know, then the caffeinated group might not think they're doing better. Basically, your body can trick you into doing better or worse if you believe that you're going to do better or worse. That's a placebo effect. The last part is 3 key elements to experimental design. We're going to talk about individual designs later, and these things are in those individual designs. What's really important is randomization of treatment. If I'm doing my experiment, I must not choose my groups. We all know about bias and how good we were at deciding from our random rectangles activity. Randomization of treatment is so important. I cannot select the groups. I must randomize who gets in each group. Replication means my design better be good. In fact, it doesn't have to be perfect, but it has to be specific enough that someone else could repeat my experiment, and just by looking at my work, just by looking at my paper, and they could get a similar result. And then control for lurking variables, that's stuff like if I know having no sleep is going to affect my test scores, then I would want to control for that. If I know that more advanced math students are going to do better on my test scores, I'd want to control for that. It's not the case, but the other thing that helps with controlling for variables is randomization. So these are tied together. Because if I don't actually specifically block to control a lurking variable, then randomization kind of at least puts some on either side, and it does a pretty good job of controlling for me. So that's the other reason we do it. All right, so next video is going to be the actual experimental designs. I crossed them off here, but I gave you papers with them. All right.